I tried to watch it because Mrs. Yoho was live streaming it. So I tried to watch it, but it kept on freezing on me, so I did it. Okay, everyone has paper, yes? Yep. Okay, so today we're going to talk about the distributive property. So we're still continuing with our study of expressions. Okay, and we know an expression contains numbers, variables, and operations. What's the difference between an expression and an equation? Who remembers? Addison?
Doesn't an equation have an equal sign?
Very good. An equation is an equal sign. An equation has an expression equal to another expression, right? So we're still just simplifying. We're not solving. We're not there yet, okay? In a couple weeks, probably about 2-3 weeks, we'll start to solve equations. So we'll figure out what that x is equal to when we get there. So today we're going to talk about the distributive property. Learning target, I can use the distributive property to simplify expressions. How many of you have heard the distributive property before right now? Okay. All right. So if I distribute something, what does that mean? Kayla?
You like separate it?
Okay, I separate something. So if I distribute the papers, what do I do? What am I doing? Right? One person is passing out all the papers. I am sharing what I have. The distributive property is very similar to that. So, formal definition for any numbers, A, B, and C. A times the quantity, B plus C. Okay, so that goes on top of your paper there. Is equal to A times B plus A times C. So when I do distributive property, I like to use arrows. So if I have A times B plus C, I draw an arrow. So A gets multiplied by B, so that's A times B. And then A also gets multiplied by C, plus A times C. I like to call the distributive property the party property. Okay? Because this person's on the outside, person A is on the outside, and wants to join his friends on the inside. So again, what do we know about distribution? Well, think about a paper person, or a paper boy or girl. What does a paper boy do? Do you know what the paper boy does? Probably not. Addison, yeah, what happens? Okay. How do you get your newspaper in the morning? Michael?
I don't.
Okay. Does anyone get a newspaper at their house?
I used to.
Okay, you used to, and when you used to get a newspaper, what happened?
My dog went and got it.
That's a talented dog, right? Okay, but they usually, the person's inside the car, right? I'll use this because it's less, okay? I'm sitting inside of the car, and then I go like this.
Yeet!
Right? Yeet, yeah. What happened? What was I doing with that? I was throwing it, right? I had all the papers, and I was distributing them to the neighborhood. Okay? Just like in a typical year without COVID, what do I do with your papers? I pass them out, right?
Gentle yeet.
Okay, yes, okay, Michael. So, distribute. We're passing things out. So, the distributive property, we can use the distributive property with numeric expressions and then also algebraic expressions. So what we're doing is we're taking our coefficient and we're multiplying it by what's on the inside of the parentheses. So, 3 times 2. Okay? And then we have 3 times 5. 3 times 2 is 6. 3 times 5, 15. And then 6 plus 15, 21. Very good. So the coefficient on the outside is multiplied by the add-ins on the inside. Do you think our process is going to change for number 2 because we have subtraction on the inside? No, it's not. But instead of subtraction, what do we classify 7 as? Negative. Very good. So remember, the sign goes with the number. When I was looking through your assessments from Friday, I noticed that some of you missed the signs. Okay, so make sure that you always keep that sign with the number. So 4 times 9 plus 4 times negative 7. So again, I distributed 4 to 9 and to 7. So 4 times 9 is 36. 4 times negative 7, negative 28. Okay. Same sign, add, different sign, subtract. Very good. So 36 plus negative 28, I'm actually going to subtract 36 minus 28 to get 8. Now, someone in the earlier class asked me, Mrs. Zadick, that is so much work. Why can't I just add 2 plus 5 and then multiply it by 3? 2 plus 5 is 7. 7 times 3 is 21. 9 minus 7 is 2. 2 times 4 is 8. And I said, Mason, that's an excellent question. I agree, right? Follow the order of operations, right? Parentheses and then multiplication. But then when you look over here, can you do G minus 9? No, they're not like terms. We have a variable term and a constant term. So we can't combine those two. So that's why we have to use the distributive property. Okay? If you have a problem like this, absolutely. Add what's inside the parentheses and then multiply. Okay? But when you have a problem like this, we can't take that shortcut. So this is where we have to use the distributive property. So 5 times G. Michael?
Can it just be
5. 5G, very good.
5 gigs.
And then 5 times negative 9. Positive or negative? Negative, okay. So we know it's going to be negative, so what other sign can we use for a negative sign? Subtraction, very good. And then 5 times 9. 45. Are you allowed to have your calculators out, ladies and gentlemen?
Yes.
Yeah. Are you allowed to have a multiplication chart out if you want a multiplication chart?
Yes.
Absolutely. Okay? So those things you can have out right away on your desk every day when you walk in here. Okay? You don't need to ask if you're allowed to use your calculators. That is something you are allowed to use every day.
Where did you get 45?
5 times 9.
Okay.
So that's let's lead into something with that answer. Okay? Up on the board right now, we just did 5 times G minus 9. And we use the distributive property to figure out the new expression, right? What does 5 times G minus 9 actually mean? Does anyone know? No. Okay. Lily, go ahead.
No, go ahead.
Are you sure?
Yeah.
Okay, all right. All right, what about this? Let's take it back a couple years. What does that mean? 5 times 9, right? But when you were in elementary school, how did they present 5 times 9 to you? Do you remember? What did you have to do? What? Right, 9 plus 9 plus 9 plus 9 plus 9, right? 5 groups of 9. And when you were in elementary school, this is just repeated addition. So we took 5 and we added it together 9 times. Or we took 9, we added it together 5 times, right? So 5 groups of 9, so it's 9 plus 9 plus 9 plus 9 plus 9, right? Or they had you draw an array. Right? Here's our 1 group of 9, 2 groups, 3 groups, 4 groups, 5 groups, right? How am I going to draw this as an array? Am I going to do that? No. But can I write this like this? If this is 5 groups of 9, then this is 5 groups of minus 9. So I could do this. I forgot what I was doing there for a minute.
I know the G and the 9's throwing my eyes off.
Okay, okay. All right, Oh, I threw it. Our eyes don't like it.
Yeah.
All right, Mrs. Doran.
Sorry. Just made my eyes cross. What's happening right now?
I should have my glasses to save you with this one.
Is that better?
Oh,
Yes,
way better.
Thank you.
Don't mess with us on a Tuesday morning.
I guess not. Okay, so I have 5 groups of x minus 9.
Was it even recording? Because if it did, that would have been awesome looking.
Is your phone okay?
That's a cool.
Sorry, friends. Hold on.
Wait, what is your phone okay?
I think my phone's fine.
I don't think you're recording though. You need to get your screwdriver out.
I know, right? See? You guys laugh. This is why I had a screwdriver all these years ago.
Oh, geez.
Only if you want to find out.
I was recording. And I'm still recording. Things I don't care about. Sorry, online friend.
Yeah.
We need to see that video.
I'll post it. I always do. Follow me on YouTube.
Subscribe.
Subscribe. Hit the subscribe button. Like you think I'm kidding right now, I actually have a YouTube channel.
Only 5%
of you in my class are subscribed.
Well, that is funny, Michael, because the other day, I'm talking to you online friends. So the other day, I posted a video, and I has been posting videos on YouTube because it's a little bit easier for the kids to access it, and they can hear me better when I use my phone. But I went on there, and I only had 5 views on my video. And then, that really hurts my self-esteem because, that kid that opens up eggs for a living has, 55 million views, and I had 5, right? So, but the saddest part about those 5 views is one of them I viewed from my computer. The other one I viewed from my cell phone. A third view came from my husband because I sent it to my husband at work so he could watch it. So I was like, because I want to make sure that on a different computer, on a different network, someone else could view it, right? So 3 out of the 5 views were actually me viewing the video. Online friend, I'm talking to you.
If anyone's
Like and subscribe.
Not that anyone's watching. Right? So,
they're gonna miss out on an awesome video.
they are. They're
Get
hilarious.
rolled out.
So like I was like laughing and my daughter was like, Mom, that is so lame. 5 views. And she's like, Ryan's Crazy Toy Time has 55 million views. And I was like, thanks, Luz. I appreciate your support.
Ryan's
I need to know what your abusive channel is. I want to watch.
Yeah. I do post it. I try to remember to post the videos. All right, so coming back over here, when we're looking at this, and I guess I should turn this way, right? Ooh, oh God, here we go. Okay, so, oh God, I'm gonna have to get in that.
Here, let me just stand here.
Oh jeez.
You
Okay,
need to
so 5 groups of x minus 9, right?
Yeah.
So how many x's do we have? 1, 2, 3, 4, 5. So that's our 5 x's. And then we have negative 9. How many times do we have negative 9 written down? 5. So that's where we get our 45. Okay? So doing the distributive property, 5 times x and then 5 times negative 9, that's our shortcut for repeated addition. Okay? So that's why we're allowed to do the distributive property. Okay? All right, so what's different, looking back on your papers?
I'm trying to help with the camera.
I know you are. She's like my boom. You know, like that. Okay. All right. What's different about this problem? There's a y. So there's 2 variables instead of 1 variable. Does that change what we do? Not at all. It doesn't change what we do. So we still distribute. 3 times 2x. I heard it. 6x. Now what do we do? Do I just distribute once? No, I have to distribute to everyone inside the parentheses. Caleb?
3 times 4y.
Very good. 3 times 4y. So 3 times 4 is our 12. And then we have our y. Now we still have our constant term, so we have to distribute one more time. 3 times negative 1 is negative 3. So another method that we can use for the distributive property is we can actually use the box method. Now you might remember the box method from elementary school, where we broke down numbers into a tens and a ones, or a hundreds and a ones, or a hundreds and a tens. And we put them in boxes, and we did our multiplication that way, and then added. So it's very, very similar to that. So our coefficient goes on the outside. And then what's in the parentheses goes up top. So x plus 3. So just like a multiplication chart, 4 times x is 4x. And then 4 times 3 is positive 12. You like that easy? That's better, yeah. So again, does it matter what method you use? Absolutely not. Doesn't matter what method you use. Okay? If you like to draw arrows and distribute what's on the outside to what's on the inside, awesome. If you want to do the box method, you can use the box method as well. So then on this problem here, 3 goes on the outside, and then our add-ins go up top. 2x 4y, and negative 1. So then again, just like a multiplication chart, 3 times 2 is 6x. 4 times 3 is 12y. And then 3 times negative 1 is negative 3. So now if they're positive numbers, what goes in between our terms? I heard it. Positive signs or addition signs, right? If it's a negative, we just use a subtraction sign. So 6x, 12y is positive, so we're going to put a plus sign, 12y, and then 3 is negative, so we're going to subtract 3. Up, down, middle. All right, for homework tonight, all you have to do, these 4. Okay, don't worry about this. Just do this right here. Yes, Addison?
I don't know if I'm thinking about something else, but wasn't there also like this cone thing where like, I don't know, you have the like expression or the equation up and then you like solve it downwards?
Okay, so that's order of operations. I think what you're talking about, you start with an expression and then you come down to one single term. Yep, order of operations, kind of the same thing, because we're starting with a larger expression and coming down to a couple terms. Kind of the same thing.